Welcome to this video about Poseidon, which is a pond control that is quite modular, built up from different parts like water level control and measuring water quality, fish feeding and so on. In this video I'm going to go through a bit about the structure and what you can monitor, and then there are other videos that you can look for those details. My name is Anders Johansson. I live in Sweden, and I've had this setup up and running now for a few seasons. So, why do you want to build a pond control? Or actually, why would you want to have a pond in the first place? That was not sure when we bought our house almost 20 years ago. That was the first thing, and it included a garden pond, and that was something that we really thought that we would get rid of, but we realized quite soon how nice it was. This is in the quite central in a small town, and some traffic noises and so on, and it's something that is really relaxing to have that running water. So yeah, that's it kind of grew on us. And being an engineer, I quite soon started to build the first fish feeder version that I had, and then it's been kind of growing from there. So yeah, I'm not really sure that I'm that interested in fishes or ponds, but I really like automation and the building. So I think this is the main driver for me, really. Otherwise, from a technical point of view, if you're like me doing quite many things at the same time, just the basic need to be able to have something that automatically shuts off when you're adding more water, if you're emptying your pond or starting up for the season, etc. And also to be able to not only to have a more binary switch on or off, but also to be able to monitor it continually for usage, or if you have leakage in your pond and so on, or just simply the evaporation from hot sunny days. Yeah, fill this fishes quite small portions and many times per day, and that's something that you more or less need a fish feeder for. And it's not included right now, but it's super simple to add some feedback loop that you see the temperature in the water, and just do it more frequently during the warm summer days where the digestion is fast for the fishes. That kind of regulated loops, I mean, that's something that I think is quite funny. Of course, if you have problems with your water quality and maybe algae or slush in the water, then to be able to monitor and address those water quality issues is something that is important. This, I think, is also a part of why you want to have a pond control. And then, as I mentioned, like the biggest aspect, for me at least, is because you can. It's fun to build, and that's why I do it. If we look a bit on the structure of the different parts here, so here is the setup for the Poseidon pond control. So this is what the top repo is containing. So it's all these services and the different sensors. And there's a movie on, if you look to the top left here, for the fish feeder. So there's a separate part on that. And then if you look to the right there you have the different level measurements. At first, I've started to use the liquid level sensor for an E-tape that is very detailed and good, but I've been shifting over to the more liquid level sensors that you have in fuel tanks and so on, like Q's liquid level sensor here. So it's the combination of, it's not only a binary switch on and off, because of course you could add that, but then you don't get you can't really see more than that, okay, it's empty or it's full. Whereas here you get some more steps and can see how the level is shrinking or rising when adding tap water. There's also a movie on this, the water control here, so the solenoids to control the tap water and flow and binding this whole together from a software point of view. Then the next movie is about the water control, the water quality and the software on that, and all the Atlas Scientific sensors and the carrier boards and whatnot. Then there's also a movie about the web GUI that I made for this, and so it's running a small web app written in Python, Python Flask. And you can read about that more or review that more in detail in that video. And then there's a video here about the how everything is bind together and the different services that are running here. So this is what we're gonna look more about in this in this video. Especially the what you can get from the Influx database, the Chronograph, which is a visual representation of data, and optionally it's also you can use Grafana, that is the equivalent. So Chronograph and Grafana, that's basically the same thing, but it's just an illustration of that you can connect different front ends or visualizations of that same data. Well, actually, the web app is using that same data also. Yep, but enjoy. When you navigate to the Chronograph address, in this case, I specified to use the ports 8888 on the local host. So when this service is up and running, when you have the full, when you have done the Docker Composer up, for example, on your services. Then you will be able to connect here, and you just navigate to this IP address. So there you have two things here. That you have the dashboards that are going to show the sensor data, and you can import those dashboards from the repo. There are two of them, and then it's these two. But now we will look at the host list, and that is what kind of data you can get from the resource usage and so on. So this is what is being reported on from Telegraph. So this is the actual metrics that you have on your on the resource uses from your Raspberry Pi. And here is going to be one, and you can see what kind of configuration that is. So it looks at the Docker instance and Docker statistics or metrics, InfluxDB, and the system, which is then, as you understand, system resources. And then you get these kind of charts of CPU usage, disk, and so on. And if you look at, for example, here we have some small peaks here, and this is then matching, it's going between 17 and 19, so it's hard to call that maybe a peak. So this is the total overall CPU usage. So if you did top, for example, use the Linux top command to monitor the CPU load, you will see roughly the same kind of average values here and here. It will probably go a bit more up and down, a bit more jitter. And by looking at here, we have this peak in time. If we look more into details there on the Docker, what the usage is in our Docker images, we can see where we find the Docker CPU usage. So at the same point in time, it's not obvious what we were using, but if you take a look at the average down here, that's mainly from the services that are not related to InfluxDB. So the CPU usage that have some difference here in the diff, that is almost always coming from the Influx database, and that will look the same for you. But you can monitor other things like the memory trends, and if you're running out on disk, and so on. It's like you see, things are often expressed in percentage, and we are nowhere near getting close to any 100% or on anything. Memory was something that was a bit problematic when I was running this on a Raspberry Pi 3 before. And especially it's the Influx database that gets clogs up after a while if it has too little memory. So that's why this needs to run on a Raspberry Pi 4. But then if we look at the dashboards, I said that you can import these ones. So it's the import is basically just some JSON file that specifies which sensor you want to look at. And there's one that is called detailed and one long-term. And the long-term one is just the same data but downsampled after 3 days. So it has a retention period where it tries to decrease the amount of data, because in this detail it actually stores every single sensor value that comes in, maybe every 3rd second or so, and it stores that for 3 days. So you have a lot of data in this one, so that's why it gets downsampled. But if you look at this one, you have some different graphs here where you can see state of water quality and feeding and so on. And if we take this is the past 15 minutes, that is the default in Chronograph. If you want to see maybe trends over a longer time, the past 24 hours, let's click on that. And so then it will change here to show the temperature. Yesterday was a pretty warm day, so this is the actual water temperature. Water that was 23 degrees, and then during night time it was at its bottom at 21 degrees, and then it starts to climb again. You can also see how much the variations in temperature it impacts the pH value. And yeah, there are other sensor values that is more of a function of the temperature also. Some of them or all of these are temperature compensated, but still you can see what happens. It's not only the temperature; it's also if it's direct sunlight or if it's shady and so on. If we look at also we have the water level here in percentage. And that is going between 91.7 down to its low point, that is 86.6 here. So if we zoom in, I thought then we can see that, there are still some slight variations here. So the reported resistance, the water level as it is right now with an Q's liquid level sensor is reporting it more or less like binary steps or in steps of maybe a few percent every time. So this is the full level or max, and then it will go down to the next step here, then you can also see the water that is on-off switch. So here between it went off, and then the next time it triggers a low point, the water turns on again, and so on. And the reason why it looks like this is because we have zoomed in on the time region. But still, you can see the water state also, how that is going. And the water flow is the number of liters that we have been adding. So naturally, if we get to this kind of point here, if you look back out in the flow layer, you see it's in time it's on the same place. So here we actually we went from 2.6 so we were adding just 20 liters basically. We went from 2.6 to 2.62. Before we actually shut off again. And so this will just increase here the water flow, the number of liters that we have added to the pond. But yeah, this is something that I think is very interesting, and to follow especially the ORP value. That is a good indication of how much debris you have in the water. And if you are at values below 250 or so, you will have lots of algae in the water, and different types of them that appear at the different levels here. So the ORP value is something that I think is very, very interesting to monitor on trend over time. And then you can select longer periods here also, but as I said, this is going to be downsampled, so you're still going to see just the last 3 to 4 days. So there's a step there between 3 to 4 days which you will see. But if you want to see longer trends on this, then you can go out to the long-term dashboard, and Like here we will see nothing from the beginning because it has the default 15 minutes. So if we increase this to last 30 days, then you see something more. You have the feeding amount, so this is the number of how much they have been fed. So you both see the timeouts, and if you have done some manual feeding and so on, you can see that. And you can monitor the trends for the different water qualities and see how that have changed over time also. So I think this is an excellent way of digging down to the details of your pond and correlate it to points in time where you did something. So it could be also interesting if you have the water level percentage, if you're filling it up, or that you're doing like a cleaning of the pond, and that then you can sort of annotate that and see if that's something that when that happens and store that over time also. That so it can be interesting to see that now the quality, the pH value went up with X amount, and that was when we're adding more fresh water, for example, and so on. Here we have an example of how it can look how this is being illustrated. So if we have the pH value, for example, if you do edit on that one, then we'll look more into the configuration of this one and where it gets its data from. So you see the same data from before, and you see the expression here that is the select from done from the influx database, and you can build it up a bit more interactively also if you want to. So it shows here the different tables that you have in your in the database. So you have the telegraph ones, and here we would see things like the CPU usage and so on. And then we have the same sample of the sensor detail, and then we have the downsampled one. So in this case, we are working with the downsampled the tables that we want to look at, and then you can browse that what kind of topics you have under that specific table. And for example, here we have all the different sensors that we have. So this is just collected on from the MQTT gateway. So all the data that are pushed there is named something PC, like pond control, and the fish feeder. Obviously that's from the fish feeder, and it's outgoing, and its feeding amount, that is the type. So that's how I named it. So this is exactly how it looks also for the messages that are being pushed. And then there's accompanied by a value for this. And then you have analog tape value, for example, the E-tape. You have the flow in liters, level, the dissolved oxygen, etc. And in this case, it was the pH value. So we're not going to change anything, but that's how it's. You can build up new dashboards, or actually combined if you want to have both EC and pH in the same graph. You can do that too. And then you can also do different kind of expressions on the, if you want to use the mean value or max sum of a certain period, the first, how it's spread, etc. And then different visualizations of this. So if you want to have just it as a table value, you can see the different downsampled values. And in the downsample, you can see that it's actually doing it in steps of 2 hours. That is the downsample values. So, or if you want to have a value in there, or some kind of gauge, or if you define it that it should be in a certain range, like a good, bad. So you can build more dashboards that are traditional in that kind of sense, that you have gauges and so on, if you want to. I'm using the charts mainly because I think that's the best way of following the trends over time. And that kind of dashboard where for the instant things, that is where I use the web app for myself, which you can look at it in a separate video. Here you can see some of the parts in the pond control. It's the fish feeder, and as you can see, I like to do the feeding quite close to the seagrass here. So they have to struggle a bit more to get the food, and maybe even out the terms for the smaller fishes also. And then right next to here I have a waterfall to increase the oxygen level, and there's also a sieve filter over here. So yeah, you see the outlets down there, and it's in that sieve filter where I have the water quality sensors, so that green part, and to the left of it you have where the solenoids are, and to the right that box is for all the electronics. And here's the Q's liquid level sensor, and obviously when the floating switch there goes too low, it's like ±5 millimeter, that will then open the solenoids for the tap water, and there's a small hose here to the left of the waterfall where you will have the fresh water coming out. You notice some pulsating there when it needs to build up some pressure before it opens the solenoids. So yeah, this is my pond and how I've used the pond control, and feel free to watch more of the other videos here to see the individual parts, and good luck.